Hey guys, so today we're going to be going over integration by partial fractions, and I'm going to try to be teaching you this as simply and as fast as we can. So let's just get right into it. So look at this. This fraction is messy, and we don't like messy. So we're going to try to break it into two tinier fractions. So here's a little tip. If you see something like this in the denominator, right? You always write, it's kind of a cue to break it up, okay? So what I mean by that is now it's going to be 5x plus 3 over x minus 1, x plus 2, I'm just rewriting that, is going to equal a over x minus 1 plus b over x plus 2. Alright? So think of a and b as two numbers we need to figure out. Your job is literally to solve for them. Alright? So let's multiply everything by the denominator. So we're going to multiply both sides by x minus 1 and x plus 2. So the left-hand side, the denominator is going to cancel, so it's going to be 5x plus 3 equals a, it's going to be multiplied by x plus 2, and then plus b is going to get multiplied by x minus 1. Right? Why? Well, let's pretend I multiplied it by x minus 1. That's what I did. I'm not pretending. X plus 2. The x minus 1s are going to cancel out, and the a is just going to be left with this. But then when I multiply it by b, the x plus 2s are going to cancel out, and the b's are going to be left with this. Alright, so that's kind of how I got the right-hand side. Alright, so now all we have to do is just expand it. Alright, so I'm just going to make this a little bit smaller. Fair warning, this does take a lot of space, so that's why I made it smaller, and my handwriting's big, so that doesn't help either. Alright, so now our next step is I'm just going to expand it, okay? 5x plus 3 equals ax plus 2a plus bx minus b. So now we're just going to group the x's and the constants, right? So it's going to be 5x plus 3 equals x times a plus b, and then plus 2a minus b. Alright, so now we can kind of do it like a little matching, right? So obviously a plus b is going to have to equal 5, because that's the coefficient of the x term. And 2a minus b is going to have, let me use a different color. 2a minus b is going to have to equal 3, because these two terms don't have x attached to it. Alright, so now we end up with the system of equations, which I'm sure you guys know how to do. A plus b equals 5, and 2a minus b equals 3. Alright, so now we just add them up, doing our normal systems of equations. So it would be 3a equals 8, right, because the plus b minus b, so a equals 8 over 3. And if I plug that back into the first equation, I get b equals 7 over 3. So now notice, we haven't done any calculus yet. This has all just been algebra. Alright, but now, let me make this smaller again. Alright, so let me rewrite our a equals 8 over 3 and b equals 7 over 3. So now, we can just become two cute tiny fractions that we can plug in over here, alright? So it's going to be 8 over 3 over x minus 1 plus b over, b we already know, so it'd be 7 over 3, sorry, my brain's not working today, over x plus 2. Alright, so now we just got to integrate this. Boom. And obviously this is dx. Now we integrate it, and it's going to become 8 over 3, right? We factor out the constant ln x minus 1 plus 7 over 3 ln x plus 2 plus c. And boom, that's our answer. So I think you guys can see, right? Like this whole part over here was just algebra. Our last two steps were the only calculus, alright? So I want you guys to understand, a lot of this partial fraction stuff is 75% algebra, and then 25% is your actual integration skills. But anyway, congratulations, you just did partial fractions. Alright, so let's go on to our next question. The integral of 7x plus 4 over x squared times x plus 3. Alright, it's going to be the same thing, okay? But, you guys see, we have an x squared. But don't freak out. When you see an x squared, it just means you need a over x and b over x squared. It was a little bit weird, but think about it. If x squared is a factor, then x is also a factor, right? And then c, right, for the other, this part, x plus 3. So yeah, you can have like all the way up to z if you want, but no one's ever gonna test you on that. And if they do, then like I think that's evil. But here we go. So what would this be? So it'd be 7x plus 4 over x squared x plus 3. I'm just rewriting the integrand. So now, like we said, it's going to be a over x, because that's one factor of x, plus b over x squared plus c over x plus 3. Alright, so if you guys are still a little bit confused on why we have the x and an x squared, the thing is, the denominator has an x squared, right? Right here, it has an x squared. So, in partial fractions, you always need one term for every power of the repeated factor. So, I'm going to say that again. You always need one term for every power of the repeated factor. Alright? Furthermore, if you try to multiply this out, you can do it and it's not going to work. Alright? You're going to be missing a factor of x. Alright, so now we're going to multiply both sides by x squared times x plus 3. So obviously the left side is going to just become this. And now, just to kind of give you guys with another visual, x squared x plus 3. Alright? Well, this a is, the x's will cancel, so it'd be ax, right? X times x plus 3 plus the x squareds cancel, so just b over x plus 3 plus the x plus 3 cancel, so it's just cx squared. Now let me just expand it a little bit more. Ax squared plus 3, ax plus bx, wow, plus 3b plus cx squared. Oh wow, that's a lot of heavy duty algebra. Alright, so now, next up, we have to match our terms, okay? So we have 2x squared right here and right here. Alright? But do you notice on the left-hand side, we don't even have an x squared. So that just means that, oh, let me use green. A plus c has to be 0, right? The x squares must cancel out. Alright, so now let's match our next ones. Let me use a blue. So our x terms is going to be 3a and b. That's going to equal 7. So that means 3a plus b equals 7. And finally, we just have 3b. Well, 3b, let me use a different color. So 3b is going to be the 4. So that means 3b equals 4. 3b equals 4. So now let me just make this a little bit smaller again. Alright, so I made it a little bit smaller again. So now we have our 3 equations, right? So remember, if you have 3 unknowns, you need 3 equations. Well, obviously, we can solve for b. b equals 4 over 3 from the third equation. And now we can just plug b into this equation. We get 3a plus 4 thirds equals 7. That means a will be 17 over 9. And finally, we can plug a into this equation. Obviously, c is going to be negative 17 over 9, right? So now we're going to have to integrate term by term, all right? So what does that mean? Well, let me just shrink this again. All right, so I kept it up there as a little cheat sheet. So now, remember, this is what we want to integrate, right? Because this equals what the integrand is, right? This is just that. So you want to integrate term by term. So now, let's do our first step. So first a is going to be 17 over 9 over x. Well, if we factor off the constant, this is going to be 17 over 9 ln x. Very similar to that previous one we did. Now let's do our second term. It's going to be 4 over 3 over x squared. Oops, I forgot the dx, which is going to be negative 4 thirds x on the bottom. X is on the bottom. And now, last one, negative 17 over. I'm not going through these integrals step by step. I'm sure you guys know how to do them. If you don't, I have a bunch of videos on my channel. This video is primarily about I want you guys to be comfortable with using these steps right here. So anyway, negative 17, right? So negative 17 over 9 over x plus 3 dx. I don't know why this integral is so short, sorry. And that's going to be negative 17 over 9 ln x plus 3. And then, again, sorry, I have to shrink this down. Alright, so now that we have all of our separate integrals, that means our final answer is going to be 17 over 9 ln x minus 4 over 3. I'm just going to make this x to the negative 1, just so you guys can see it a little bit better. Nobody gets confused. 17 over 9 ln x plus 3 plus c. And boom, that is our answer. Alright, so you guys see, even with repeated factors, right, that x squared, it's the same process. So you're going to be chilling during your test. Alright, next question. So, again, we see these two terms multiplied in the bottom. We're going to have to do our decomposition. I'm going to try to write smaller this time. So, take it out. And obviously, guys, pause the video and try to solve it yourself. And then come back and check your answer. This is just going to be a over x plus 1 plus b over x plus 4. Multiply both sides by the denominator. It's going to be 3x minus 2 equals a times x plus 4. I'm going a little bit faster on these ones because you guys probably got the hang of it now. So it's just going to be 3x minus 2 equals ax plus 4a plus bx plus b. Now, if you're having trouble going from this step to this step, just literally write out the multiplication. 3x, it'd be x plus 1 times x plus 4. Right, so you see the x plus 1 cancels for the a term, you're multiplied with x plus 4, and vice versa for the b term. Alright, so now we try to find our little terms. Alright, so our two x terms are ax and bx, and that must equal 3. So that means a plus b is 3. And then we're left with our constants, quote unquote constants, for a and b, and that has to equal negative 2. So that means 4a plus b equals negative 2. And now all we have to do is do a little system of equations. So it would be negative 3a equals 5. So that means a is negative 5 over 3. And then if we plug that into here, you're going to get b equals 14 over 3. If you plug negative 5 over 3 into this equation, you're going to get b equals 14 over 3. You could use a calculator for this, right? Or don't. I mean, this is pretty simple fractions. I'm sure you guys can do it. Alright, so now same steps. We're gonna try to integrate term by term. So, it's gonna be integral of here. We plug these a and these b's into this equation right there that we made. Alright, so it's gonna be integral negative 5 over 3 x plus 1 plus 14 over 3 over x plus 4 dx. Alright, so there we go. And now what do we get? Well, we factor out the constant. It's going to be negative 5 over 3 ln x plus 1. So you guys notice we're kind of getting a lot of ln's. And I don't want to say that this is going to happen every single time. Most likely it will. But I saw this really weird question where it didn't happen. I don't even know how. But usually it does have an ln in it. Alright? Plus c. So there's our answer. Alright? So if you survive this one, you're ready for the final question. Here it is. 6x plus 5 over x minus 2 squared dx. Alright, so the same thing. Remember when we had that x squared? Well, it's the same thing, right? It's going to be just, we had the x and the x minus x squared factor, right, on that previous problem. So what I mean is, here, right, we had the x and the x minus x squared factor, so we're going to do the same thing. We're going to have a, let me just rewrite this, sorry. Should have rewrote that first. We're going to have a x minus 2 plus x minus 2 squared, right? Because you want to have it for every power of the denominator, alright? So, a plus b. And now we just do our regular thing. So if you multiply by x minus 2 squared, obviously the left side is going to become just 6x plus 5. X minus 2 squared, we're going to get a times x minus 2. and then plus b. Now we're just going to expand. 6x plus 5 equals ax minus 2a plus b. So match our coefficients next. Well, this is our only x term, all right? And then this is our only constants. Boom. All right. So it looks hard, but I'd say this is probably one of the easiest ones we've done so far. So obviously a equals 6, and then negative 2a plus b equals 5. So then that should be negative 12 plus b equals 5, b equals 17. All right, so now we just plug our a and b values, up to here. All right. So this is going to end up being 6 over x minus 2 plus, here, actually, you know what, I'm going to split it because the denominators are going to be different. Dx plus integral 17 over x minus 2 squared dx. This will be like how we did 6 ln x minus 2. And then this one over here will be the integral of 17 over x minus 2. And now, is that our answer? No, because we forgot the constant of integration, but boom, that's our answer. So, I hope you guys learned a lot in this video. These are pretty much the hardest ones you get, especially the repeated factor ones, like this x squared or the x minus 2 squared one that we just did. But that is basically all you need to know. So if this helped, drop a like, drop a sub. If you have any questions, leave them in the comments below. Or if you have any videos you want me to make next, also leave them in the comments below. Thank you guys so much for watching. And I'll see you guys in the next video.